So they are saying the first, the speed is 10 meters per second, and it's thrown horizontally. So we are having, you can picture it like this. This is the case that we are having. So this thing is thrown, projected like this. Then it starts to fall. We were aiming to hit P. That was our aim. But then we don't hit our P. We hit Q, somewhere here down. That's where the thing goes. So now they're asking for this distance. This is like our height, this distance here. This is like your height. The velocity with which this thing is released in. So at this point, it's in the horizontal. When something is moving in the horizontal, it simply means it's in the x-axis, meaning the velocity in the y, or the y component, is 0 at that particular point. So here we're going to say the velocity in the y is 0. Then the velocity in the x is the one that we are given, which we are starting with, which is the 10 meters per second. That's what we have. Then they're saying what? Vertically this, the time has been given. What is the distance? P, PQ. So PQ being our height, the time given. What can we do with the time that has been given? And we're looking for a height. The time is 0.19 seconds. So how else do we get this distance in y? You do the distance in y is equal to, we're supposed to do initial velocity in y times the time plus half. This is supposed to be g, then t squared. Then this is going to be, the initial is 0, so put the 0. This is just direct, then plus half. We're going down, so that is the same, in the same direction as gravity. Then we have 0.19. Then we square this. So meaning our height is just your 0.5 times your 9.8, then times your time squared. This is how you're supposed to get the distance. PQ, that's your height. Is this okay?
Okay, I was just wondering if what I did was correct, because I also found it. I used this formula now just to show at least one more answer.
Oh yeah. This is how it was supposed to be done. Yeah, so this is you getting your P. Then after that, they're asking for the range. How far away does it fall from the initial thing? So range, you know, to say range is just the velocity in x times the time that you have. So the velocity in x is always going to be the same, then times 0. This will give you 1.9 meters. That's simply the range. So that's, you found the same, right? Yeah, so this one is okay. Question 1 was okay. Okay, so let's go to question 2. Question 2, I think they actually reversed the things. It's the same thing, but they just changed how they phrased it. Because here they're saying a small ball rolls horizontally off the edge of a tabletop that is 1.2 meters high. So they've already given us the height. It strikes the floor at a point 1.52 meters horizontally from the table. So the range and the height has been given. They're doing the opposite to see if we can go back in reverse. It's the same thing, but they have now given us the height has been given and the range has been given to us. The height is what? 1.2 meters. This is 1.52 meters. This thing just rolls off and falls off like this. So meaning if it's rolling off, there is velocity in the y is 0 still at this point. We don't know the velocity in the x because it's going in the x. We don't know this guy, the initial velocity in the x. Then is it, yeah, this is the guy, then this is that. Then they're saying what is the speed at which, okay, they're asking for the speed, the velocity, then how long is the ball in the air. They're asking for time, the things that they gave us in the first question. That's what they are. There's velocity and time. So we're going backwards now. So implying that we can use what equation here? We have the height, we have the 1.2, we know the velocity in the y-axis is 0, so we'll just have this, then times g, then t squared. We can get our this is going to be 4.9 t squared. Then you have your 4.9 divided by 4.9, meaning your t is just the square root of 1.2 over 4.9. This will give you your time. Then the same time that you've gotten here, you use it to get the the velocity, because the range we said is the velocity in the x times the time. The time you get here, plug it there. The range is this guy here, you can plug it there. Then you get your velocity in x. That's the velocity with which it was rolling off in the horizontal. Is this okay? So now question 3. Question 3, they're saying a projectile is fired horizontally from the gun that is 45 meters above flat ground, emerging from the gun with a speed of, they're saying a projectile from a gun that is 45 meters above flat ground, emerging from the gun with a speed of this 250. How long does the projectile remain in the air? At what horizontal distance from the firing point does it strike the ground? What is the magnitude of the vertical component of its velocity as it strikes the ground? So this guy here, it's a gun which is 45 meters. So this is our question 3. So we're just saying if you're shooting it from this point, this is 45 meters. When we shoot it here in the horizontal with a velocity of, so the initial in x again is 250. We didn't shoot it at an angle, so it has to be straight. It will fall off like this. So they're asking for the time it takes, the time of flight, the time it's in the air, and also they're asking for the range. And you notice that they're asking for the vertical component of its velocity as it strikes the ground. So we know to say the velocity in the x is always going to be the same, but the velocity in y is constantly going to be changing. So they're asking for this. What is the velocity in the y, I mean, just before it strikes the ground? Because we know once it strikes the ground, it will be 0. It will be back to 0. But we're just saying just before the moment it's about to strike the ground, that's the velocity in the y that they're asking for. Yeah, so first of all, we get the time. Since we know the speed that we are out, this will help us to get the range. I mean, we need to get the time first. We have the height. So the time that was needed to achieve this height, since we are going here in the y-axis, is what? Is 0. Yeah, so let's say it's 0. This is why the initial is 0. The time it takes for it to fall down, to come down like this. Yeah, so this is going to be from a height of 45, the initial will be 0. It's the same thing we do. So this will give you the time. This will be 45 divided by 4.9. So if you punch this, what time do you get? 3 point? Okay, so if you get this to be your time, we can now get our range. The range is just going to be our 250 by this same total time here. So this can give you the range. Now we're interested in the velocity. This is the velocity just before it hits the ground. Yeah, so how did you manipulate to get the velocity vy? Oh, okay. Yeah, so magnitude is simply the size, right? So this is 0, then we have g, 9.8, then times time. This is what? 3.03. So we're just using this equation, the one that this guy here. So the velocity, final velocity is just initial plus acceleration. Acceleration is g. So have this. When you multiply this, what do you get? 29 point. Okay, so whatever you're getting, let me just say approximately that. This has to be, you put a comment here in the negative direction because it's pointing down. Yeah, you have to put this. Yeah, so you need to put, say this guy is actually in the negative direction. So this is going to be the velocity with which it's going to be having or striking the ground with. Then the next one is question 4. So question 4, they're saying in 1991, so this guy, Mike Powell, jumped 8.9 meters. That was his achievement, breaking a record by a difference of 5 centimeters, from what Bob did. So meaning the difference was simply 0.05. So Bob had 8.9. So assume that Powell's speed on takeoff was 9.5 meters per second, about equal to that of a sprinter, and that G is this. In Tokyo, how much less was Powell's range than the maximum possible range for a particle launched at the same speed? So everything else, we're just going to get his, so Mike Powell, question 4, so Mike Powell achieved a range of 8.95, right? Factoring in he's a person and everything else, his mass and everything else, so he achieved this. But then we're saying, what if we just launch another particle with his same velocity, the velocity that he was, or he had? So this is going to be launched this manner. This is what you have. So this is like those things that those people, I don't know how we used to call them in high school, those who do those type of jumping. I don't know, is it, have they given us a name here? There is so is it what? He jumped. Just jumping. You know how they run, then they come jump, right? Then they put some, I don't know, in high school they put some sawdust for them to land safely on the other side. So this is just like normal jumping. And in a case where they give you this question and they don't mention an angle, we always are going to be using 45 being the equal distribution of the x and the y component of the velocity, because we are cutting the whole first quadrant in 2 equal parts. You're getting your maze, right?
Yes, so to get the maximum range is to use 45.
We get 45, yes. That's what we're going to use. So the velocity that is given, the velocity was 9.5. So in Tokyo, gravity is 9.8. So we have the initial velocity is 9.5 meters per second. We're going to resolve it into the y. It will be 9.5, then sine 45. Then here you have the velocity, the x is 9.5, then cos 45. So they're asking for the range. What is the gap, the difference in the range that a particle can accomplish and what Mike Powell accomplished? So we can get our time first. We do the time of rise. So we use the normal way how we do things. We're going to say at this point, the velocity achieved is always going to be 0 in the y-axis. So if we're going up, we need to get this height there. So if do we really need to get the height? No, we just need to get the time, then multiply it by 2, because the total time of flight here, T1 is equal to T2, right? What happens here is the same as what happens there, isn't it? So here we're just going to say the gravity is negative 9.8 because we're going up from here to here. We want to get the time. Final velocity there is 0. Initial velocity is 9.5, then sine 45. Then divided by the time. We don't know what the time is, so time is going to be T1. 9.5, you can cancel the negatives. 9.5 sine 45 over gravity in Tokyo, which is 9.8. So T1 gave you what?
Yeah, 0.68.
0.68. Then you multiply this by 2.
It gives 1.3.
1.3. 7. So if this is our time of flight, we can now just get the range. The range is going to be equal to the velocity here, which is 9.5 cos 45. So when you multiply this by the time we've gotten, what do you get?
You get 2.48.
You're getting
2.48.
The first part, I'm not getting what you're saying.
2.48.
2.48. So you multiplied, just a minute, let me just check here. So you're getting, the time you're using is the 1 point, okay, the 1 point, so this is what you first of all had 9.5, or rather let me just punch this first. You punch the trig, this is what this course, I mean course, okay, just a minute. So first of all, you start with the cos 45, which is this. So this guy then times 9.5 is giving us 6. Then this guy times, you're saying 1.37. This is giving us 9.2. Yeah, so I'm getting 9.2 here in Umezi because it's supposed to be big than 8.95. Yeah, this is going to be a 0. This is what I'm getting. So just start punching 9.5, then cos 45, get your answer. That answer you get multiplied by the time. So now that we get the range, the actual range that a particle traveling with his speed is going to actually achieve this, probably maybe it's lighter or something. So the difference is what they want. The difference is just going to be the 9.2 meters, then minus the 8.95 that he achieved. So we're just going to say our answer. So this answer that we've gotten minus, we say 8.95, it gives us 0.25. Yeah, so 0.25, this is the difference. This is what they wanted. Coming to number 5. Number 5, they're simply saying the current world record motorcycle jump is 75 meters set by Jason Rainey. Assume that he left the takeoff ramp at 12 degrees to the horizontal and that the takeoff and landing heights are the same. Neglecting air drag, determine his takeoff speed. So meaning, you know how those motor things are. So like they come from, let's say, I'll do something like this to make this make sense. So let's say the ramp is here. There is where they're supposed to come here. The angle is the 12. That's the 12. I mean, this is supposed to be 12. So if this is 12 degrees, then they're saying the height he achieves to jump and comes to the same level from where he jumped from. So this is the same level where he's going to land. It's the same level as compared to the height where he started from. So this height achieved here is what the 77 meters given to us. So we don't know his initial velocity. That's what we are looking for. But we know the height here. And we know how we get our height. Height is just going to be equal to what? Height will be the initial velocity in the y, then times the time, then plus the what? We can say plus what? We can say plus half, then g, then t squared. This 77, I mean, this is 77. Then there's also another equation we can, in case we're looking for time, what do I say? Time is equal to the final velocity. I mean, it's going to be what? The initial, it's coming from here. G is equal to 0 minus uy over t. So if I make t the subject, it will give me this. That's what I'm having. The velocity in the y component divided by the gravity, the gravitational acceleration. So we have this. Yeah, so which other formula can we are we going to need here? Because they are saying there's no range given. They're just saying the height to the horizontal that the takeoff is this. So what do we do here, Nyumezi? What's the first thing that we do? if you cross multiply, we're going to have a 77 negative with 2 and 9.8, then giving us, this is a negative, then we're having a u sine 12 squared, then the negatives can go, then we are simply going to say we square root this side, so the square root of 2 times 7, then we have 9.8 is equal to u, then sine 12 degrees. So we can actually get the velocity directly from here by dividing by sine 12. So this is the quicker way that you could have gotten your velocity, the initial velocity, before it's resolved, like the u. Yeah, so we're using this equation of height or distance that doesn't have time, that doesn't require us to find time. Yeah, so hope this is okay. Is this okay? Yeah. However you try to manipulate it, the answer must be the same. So it's just understanding the question and visualizing it. Yeah, so no wonder why we're doing that. Then the next question here, they're saying, so here they're saying a stone is catapulted at t is equal to 0 with an initial velocity magnitude of 20 meters per second and at an angle of 40. So the time is 0 at the beginning above the horizontal. So we're just saying what are the magnitudes horizontal of its displacement from the catapult side at t is equal to that. Repeat the c horizontal x component this. Okay, so for you guys that are doing 10, 15, they don't really ask about such, but if we were to just do it, this is going to be, the angle is given to be 40. So this is question number 6. So they are saying this thing is catapulted at an angle which is 40 degrees. The velocity is given to be 20 meters per second. This is 20 meters per second. Then they're asking about, so here they're saying, what are the magnitudes of the horizontal? Initial velocity magnitude is that at an angle of this above the horizontal. What are the magnitudes of the horizontal and vertical components of displacement from the catapult when time is, so the time has been given to be t point. So it's like they're giving you the time for the rise at each particular stage. So I'll just do for this one. It's the same thing that you do for every other time that they'll give you. So the time is 1.1. So we're just saying what will be the displacement in the x and y. So what will be the range? So let me just show you here. We're just saying what will be the range when the time matches. So what will be the range in the time 1.1? Then also what will be the height? We know there's a maximum height where it's going to reach, but we're just saying what is the maximum height achieved at this time? Maybe the maximum height is there, then it falls on the other side, right? But they are limiting the time to 1.1 seconds. So what will just be the achieved height? This is the y component of the displacement. This is going to be the x component of the displacement. So in terms of y, we know how we get the height. The height in y, you resolve this into x and y. This will be uy and also ux. So you have your 20, then your cos 40, and you have your 20, then your sine 40. So now you have to get, so we don't know at this, we're making this to be like our maximum height. So if this is your guy that you achieve, meaning at time this is where we are stopping. So meaning the final velocity there has to be 0. So if the g is taken to be negative 9.8 and the final velocity is 0, we're having 20, then sine 40, then over. Oh no, the time is already given. Sorry. The time is given, so we're not even looking for it. Yeah, so we need to go straight forward to look for the vertical component. So the y is just going to be the initial, which was 20 sine 40, then multiply 1.1. That's what we are given, plus half. We're going up, so the g is negative 9.8. Then we're having t 1.1 squared. So this gives you the y component of the velocity. X, we're just getting the range at 1.1. It's like this is our time of flight. So the range will be 20, then cos 40. Then we multiply this with our time. That's what they want. So at t, 1.10 seconds, the height will just be the answer you get there, and the range will be that. So it will be changing. You increase the time, you increase the values. You're going to notice that the range and the height are both going to be increasing as you increase the time. Yeah, because you are prolonging the amount of time that you are in the air. So that's the main reason why you see that the displacement in the X and in the Y, in the vertical and in the horizontal, are going to be increasing. So that's what we do here for every time that was given. T this, T that. That's what we do. Is that okay?
Yes, it is.
Mm-hmm. So for these, you guys doing 10. I mean, oh, you are doing